Hello everyone. Today we are going to talk about stop loss insurance. To talk about stop loss insurance, we first need to talk about the aggregate deductibles. An insurance policy can impose an aggregate deductible. In contrast to per claim deductible, an aggregate deductible is applied to the aggregate loss S. So this S minus D plus will be equal 0 if S is less than or equal to D. It will be S minus D if S is greater than D. Such insurance is called stop loss insurance. The expected cost of the insurance to the insurer is called the net stop loss premium. Similar to an individual payment, the aggregate payment visible or variable with an aggregate deductible can be expressed as S minus D plus that will be equal to S minus S cap at D. Because the distribution of S can be difficult to determine, there is not a consistent formula to calculate the expected value of S minus D plus. The rule of thumb is to identify patterns and apply basic probability principles. Fortunately, in this exam, S is usually discrete for this type of question. Now let's look at this example. For a collective risk model, the number of claims received by the company has a geometric distribution with a mean 3. The individual loss amounts have the following probability function. Probability x equals small x is equal 5 minus x over 10. X is equal 1, 2, 3, 4. An insurance covers the aggregate loss subject to a deductible of 2. Calculate the net loss stop loss premium. So how do we solve this? First, for the question, the M, the frequency, follow geometric distribution with parameter 3, and the loss amount can be 1, 2, 3, 4 with probability of 0.4, 0.3, 0.2, and 0.1 respectively. So the net loss premium we can calculate as expected value of S minus 2 plus, which will be equal expected value of S minus expected value S cap at 2. So start with the expected aggregate loss, which requires the frequency and severity means. You need both expected value for frequency and the severity to calculate the expected aggregate loss. So we first calculate expected frequency EM we equal 3. This is based on geometric distribution. Then expected severity X will be equal probability times the value X, and you sum them up. So it's 0.4 times 1 plus 0.3 times 2 plus 0.2 times 3 plus 0.1 times 4, which is equal to 2. So your expected aggregate loss ES will be equal to 3 times 2, which is equal to 6. Now to calculate aggregate loss limited expected value, construct this table. Aggregate loss S would have 0, value 0, value 1, and value greater than 2, greater than or equal to 2. Probability, we can talk about it in the following, but the S capital 2 will be equal 0, 1, 2. Now let's look at the probability in the middle columns, which are calculated as follows. If the aggregate loss is S equals 0, it means your probability of frequency is equal to 0. That's probability of M equals 0. In this case, we know the probability n equals 0 will be 1 over 1 plus 3 equals 0.25. Now probability of s equal 1, which is the same as probability of m equal 1. You have to happen once, and in this once you have your x would have to, the claim would have to 1. This is the only way to have an aggregate loss of 1. So you can utilize the geometric distribution to calculate probability of m equal 1, and you times probability of x equal 1, which we already know is 0.4. So you get 0.075, which is the probability for aggregate loss equal 1. With this, you will be able to calculate the probability of s greater than or equal to 2 would just be the 1 minus 0.25 minus 0.075, which is equal to 0.675. Now we can calculate the aggregate loss limited expected value from first principle. So expected value of s cap at 2 would equal each of the aggregate loss cap at 2 times the probability of s equals small si. So it will be 0 times 0.25 plus 1 times 0.075 and plus 2 times 0.675, which is equal 1.425. Therefore, the net loss premium expected value of s minus 2 plus will be equal 6, which is es minus e s capital 2, 6 minus 1.425. So it's equal 4.575. Alternatively, to calculate the expected value of s minus 2 plus, it's to start with expected value of s minus 2 and make adjustment where there's a difference between s minus 2 plus and s minus 2. We can construct a table like this, and we can see the difference only lies in the first two rows. The rest of the rows, they are the same. Therefore, we can calculate expected value of s minus 2 plus to be expected value of s minus 2 plus 2 times probability of 0 and 1 times probability of s equal 1. And from there, we can see we already know this expected value of s minus 2, it will be equal to expected value of s minus 2 plus 2. Probability of s equal 0 is 0.25, and probability of 1 is equal to 0.75. So that would become 6. Expected value of s is 2.3, 2 times 3, which you already know, minus 2 plus 0.5 plus 0.75, 0.75. So this is 4.575. You will get the same result as before. Now let's look at the second example. The number of claims follows a logarithmic distribution with the following probability function. Probability of m equal small m will be 0.9 to the power of m over m log 10. M is 1, 2, 3, etc. The amount of each claim is 80. Reinsurance covers 80% of aggregate claims in excess of 200. So to solve this problem, first we write out the reinsurance net premium, which would be equal 80% times expected value of s minus 200 plus. So that will be equal 0.8 times expected value of s minus expected of the s cap at 200. Look at the logarithmic PMF in the exam table and compared to the PMF provided by the question, the parameter beta has a value of 9. Therefore, expected value for m you can be calculated to be 9 over log 1 plus 9, which is equal to 3.9087. Then claim amount is a constant of 80 per claim, so expected value of x is 80. So expected value of aggregate loss will be 3.9087 times 80, which is equal to 312 times 0.6920. Now we can construct the following table for s equal 80, 160 or greater than 200. And we know the value s cap at 200 will be 80, 160 and 200. For anything that is greater than 200, you will get 200. And then we need to calculate probability of s for s equal 80, s equal 160, and s greater than 200. For s equal 80 is the probability of m equal 1 and x equal 80, so which can be calculated as 0.3909. Similarly, for probability of s equal 160, it means your probability of n will equal 2. So you can get it as 0.1759. Then probability of s greater than 200 can be calculated by subtract this 0.3909 and 0.1759 from 1. You got 0.4332. Therefore, the aggregate limited expected value E s cap at 200 can be calculated to be 146.0606. Then from here we can calculate the reinsurance net premium by using the formula we wrote in the beginning. So the final result 133.3051. We can see this example is actually pretty similar to previous one. You just have to write it out, construct the table, and calculate the probability for those small amounts. Then the rest of the probability will be easier by using 1 minus the probability you calculated. Then the rest is just using formula to calculate the expected value of s minus d plus. So